Hello, today I'll be talking about the cube at the center of the iron nucleus, and the cubes in carbon through uranium, and it's very common. So there's a couple of things that happened at first during the year 2015. I put together a random collection of 32 protons and neutrons, and I was never really satisfied that iron could be modeled this way. I had selected iron because of its amazing magnetic properties. Now, to evaluate the theory of the cube, I did this in 2017, and it was a static theory that the nucleus would be a stack of protons and neutrons, and not chaotic and not dynamic, just based on a cube. And it turns out that there was a easy way to calculate something for this iron 57 cube. Iron has two common isotopes like 56 or 57 protons and neutrons. That's called A, the mass number. And then Z is the number of protons, 26. And we see that when you use a cube theory, these integers work out very well for these groups of numbers, where 57, the number of protons and neutrons in iron, is 27 plus 6 times 5. A cube has 6 faces. So on each face of the cube, we would have 5 protons and neutrons. And the Z is 26, which is 8 in the cube, and 6 times 3, because the cube has 8 corners and 6 faces. So on each face, there would be 3 protons. And it turns out that this is similar to lithium, where lithium is rare in the sun, but iron is 10 million times more abundant. Apparently, lithium has been absorbed by these cubes, producing iron. Now, another point I wanted to raise on this is that I wrote a paper last year called Ferromagnetism from Iron's Nuclear Structure. And it has this face-armored cubic lattice, so that there's a certain crystallographic type of lattice for this. And I've found that the cube 2 by 2 by 2 is stable, but not 4 by 4 by 4. So this is because the 4s have, at the center of the cube is a vacuum. And also the 2 by 2 cube is, a vacuum is at the center of this. For example, here's the model. You see there's 2 protons there in white, and just like there's a 2s orbital at the core of atoms. So I'm pretty much certain that there is a cube at the center of iron because of all the evidence that I've found. Let me try to tell you about a quick list of the evidence I found for this, and that technetium is lightweight, cerium and iron spark when struck. And you can just read a bunch of these bits of evidence here. And but I'm also going to show you a couple of nuclei. So we can see over here the gadolinium nucleus right here. It's much bigger than iron right here. And you see they both have this pyramidal cube structure that results in a ring, 2 rings of protons. And the same for gadolinium. This gives me certainty that this is the correct theory. Other elements are not like this. I evaluated all the elements, 118 on the periodic table, and only gadolinium, cobalt, nickel, and iron have these 2 coaxial loops. So that I'm very certain about this. So here is the famous cube, 3 by 3 by 3. There's a proton at each corner. And thank you very much for listening. My name is Alan Falmsby.